We're going to do a two-sample t-test using SPSS. So here's the original problem. They have a new drug that will lower your lipid, that's your bad cholesterol. So they're comparing a experimental group with a control group, and these are their lipid counts rounded to the nearest 100ths. And it's in an Excel spreadsheet. So what we're going to do is transfer this over into a SPSS spreadsheet. So let's go to SPSS. So here's a blank SPSS sheet. Let's go back to our data sheet. So we have 21 subjects that received the drug, 21 subjects that did not receive the drug. So that means we have a total of 42. So back to SPSS, we need to make a variable. Let's just call it subject. And instead of putting their names down there, we're just going to give them numbers. Okay, so let's give them 1 through 42. All right, I'm going to pause this. Will I do it? All right. I don't like all these decimals. Because they're just single digits with no decimals, we're going to go back into variable view. We're going to change the decimal down to 0, just so it looks better. All right, so we have our 42 patients. We need another variable, something that will put each one of the subjects into either the drug group or the control group. So that's the key word there is group. So we're going to name our IV group. Okay, it's a categorical IV. So we need to set this stuff up in the SPSS. We need to tell it what kind of variable it is. So we're going to use a numeric width. Don't worry about that. That tells you how many characters in the title of your variable is. Decimals. Again, we're going to just make this either a 0 or a 1. Label is, we'll just call it a group again. So here's your money right here under values. Boom. We're going to make the control group a 0. That means they got no drug. Control. Spell it right. You're going to add it. We're going to click 1 in the value box, and that's going to be the ones that got the drug. Okay. This is a splitting variable. Okay. I'll say it again. The IV has to be group with a t-test. That's how SPSS works. Okay. So we don't worry about missing columns. The type of measure it is, this is a nominal variable. Nominal is the same as categorical. I use the word categorical because it reminds me so much easier that it's going to put everybody in the subject into one category or the other. And we don't need the rest of that. But now we need to go back to the data view. And we have to decide which subjects were in the control group, which subjects were in the drug group. So we're going to look back at our sheet here. So number... We'll just make the first 21 the drugs, okay? And in the second... from 22 down to 42, we'll make them the controls. Okay, so back to SPSS. So the first 22s are going to be zeros. So hold on while I plug that in. So now we're at 22, so we're going to make the next set of 21 people the ones. They're the ones that got the drug. So hold on while I plug these in. I'll fix them. Hold on. Okay, so now if you look at it, you can see half of your people are in the control group. The other half are getting the drug. So now we're going to go back to our Excel. I think the easiest way is to just try to cut and paste it. So box it. I always hit copy. Hopefully this will work. Go back into the first one. We're going to put paste. Bam. See that? So now let's go back to the second group. These are all the control group. Right click, copy. Back to Excel. Paste. So we have all the numbers, but now we have to go back and name this variable. Okay, so back to variable view, you just click in that box. We're going to name this just lipid count. Oops. Very important with SPSS, you can't have any weird symbols like apostrophes or blank spaces under name. So we always use underscore. Okay, so we have a lipid count variable. And we do need decimals here, so we'll leave it to the 0.2 decimals. Label, we'll just call this the DV. It's the dependent variable. Values, we don't need to worry about values because this is what we call a ratio variable, a continuous variable, a scale, just a regular counting number. That's how you remember that. And let's take one last look at it to make sure it looks okay. We are good to go. Okay, so now we're going to go ahead and do a few tests on this. First thing you should do is to check out the data real quick. Normally I just go to Explore. And we're just looking at the DV, right, lipids. You can see here, right, let's look for outliers. We always look at the histogram. We could look at the stem and leaf as well, but histograms are so much easier. And if you guys don't know what a normal plot looks like, click that. And always check your options. Nah, we don't need that. So click OK. So this is going to tell us if our data is basically normal or not. Okay, we got 42 people. That's good. Nobody's missing. That's good. The mean is right around 49.5. You look at your skewness numbers. If they're under 2 roughly, you're okay. You look at your kurtosis, it's okay. It's not, the data is not perfectly normal, but it is within using ranges. So these are the extreme values. That doesn't necessarily mean that it is a outlier. Okay. So to check for a normal data set, we're going to look at the test of normality. The number one we look at is I just call it the Smirnoff because I can't pronounce that first name. So you get the Smirnoff test. If this significant number here was less than 0.05, that means your data is not normal, which means you should not use a t-test. The backup one is the Shapiro-Wilk test. And again, if this number was less than 0.05, you would have trouble. You would not be able to assume the data was normal, and you would not proceed. Another quick way is to look at the histogram. It is relatively normal, minus a tooth here, okay? It doesn't have to be perfect. But remember, a normal data frequency curve has most of the stuff in the middle, and we do here. And you got your normal QQ plot. Most of these dots wrap around this straight line here as a snake. You do have a few outliers out here, but again, I don't think anything enough to worry about. These could be these two could be outliers. So let's look at the box plot. The box plot will tell us, and it says yes, number 17 is in fact an outlier. So remember, this number up here tells you the subject number, not the value. So let's go look at number 17 on our SPSS. Thank you. All right, there it is, number 17. Yeah, 87.7, that is high. I'm going to take it out. Goodbye. Just click that button and hit delete, it's gone. Okay, so the data should be relatively normal now, so we're going to continue. Okay, let's do our t-test. You're going to go to Analyze. Compare means. Oop, compare means. Bam. Independent samples t-test. Okay. We could have used the paired t-test. All that means is you have the exact same number in one group as you do the other one. But so in this box, the test variable, that's going to be your DV. Your group goes into your grouping variable. That's why I keep insisting that we name these things group. And then check the options, see what we got here. Nah, nobody's missing. And we're going to define the groups. So remember, group 1 was 0. Right? That was the control group. Group 2, we marked with a 1. Those were our drug guys. So we're set to go. Click OK. Here's the output. So it showed the means here between the control group and the drug group. So it basically ran an F test. An F test is a T test. They're both related. But when you have more than 2 groups, it becomes an F test. But when you only have 2 groups, we still refer to it as a T test. But we're going to go into that later. But we got a very small F statistic, which caused a very huge significance. If this number was less than 0.05, then we can reject the null that stated that there was no significant difference between these 2 drugs. But because this was not the case, we cannot say there was a significant difference here. In other words, the drug does not lower the lipids like it claims, okay? And again, there's the significance of the test. This has to be less than 0.05 in order for there to be considered a significant difference, and there wasn't. And another way to not reject the null is if your confidence interval, right, this is a number line between -8 all the way up to +7. If 0 is in this interval somewhere, you cannot reject the null as either. So, but that's it in a nutshell. MGZ out.